Everybody, I'm going to talk about how to convert names to structures in this video. So there's going to be a pretty step-by-step method that we're going to want to do. So the first step, we need to identify the parent chain. Okay, then we're going to identify the main functional group. We're going to draw the chain and number it, and then add the substituents that are listed in the name. Okay, so what we're going to do first, I tend to look at the end of the molecule first. That's where you're going to find the parent chain information. That's where you're going to find the main functional group. Okay, so if I go and look at, I'm sorry for the dotted lines, I didn't have to get rid of that on my iPad. So if I look at the very, very end, I've got al. So that indicates that I have an aldehyde. Okay, so then if I look to the left, and it's kind of weird because the easiest way to do it is right to left reading, not left to right. So if I look to the left of that, I have hexan. So the hex is going to be 6 carbons. The an is going to be sp3 carbons. Right, so that's indicating to us, hey, I've got an sp3 carbon chain that is 6 carbons long. So then I have isopropyl. That is going to look like this. And it's never a bad idea to draw out the shapes just as kind of notes so that you have it all drawn out a little bit. So the isopropyl group is going to go on carbon 3. Then we have the dimethyl piece. So that's going to be 2 methyl groups on carbon 4. Okay, because we're always going to use the number that's in front of the piece of the molecule that it's talking about. So in this case, it's going to be that isopropyl group on carbon 3, the dimethyl on carbon 4. And then over here at the last, we've got 5-bromo, which is just going to be a bromine on carbon 5. Okay, so if you're ever wondering how these all get put together, it really depends on what's your major priority substituent. And then you have your number of carbons. And then these are just organized by alphabet. So bromo is B, methyl, and P for propyl. Okay, the little prefixes don't count in those. So you got di or tri or anything like that. Okay, so second step, we need to go ahead and draw out the chain. Okay, so I've got 6 carbons, 1, 2, 3, 4, 5, 6. Excuse me. So I've got my 6 carbon chain. It is important to note if there's a cyclohex or something or a cyclopent, then you'd be drawing your parent chain in a ring rather than in a straight chain. But nothing in here is telling me that it's a cyclo compound, so I'm just going to keep it as a straight chain. Okay, so then on carbon 3, I have my isopropyl group. So isopropyl group there. On 4, I have 2 methyls. On 5, I have a bromine. And I still need to deal with the fact that I have an aldehyde. And just remind ourselves what an aldehyde looks like. Something like this. So because we have to have an H on the end, the aldehyde can only be at the end of a chain. Okay, it can't be in the middle of a chain, otherwise it's going to make it a ketone. So in that case, that aldehyde is always going to be on number 1. So on number 1 over here, I have an aldehyde. Okay, and I added the H here. I'm very careful not to add another carbon to change it into a ketone. All right, so let's look at the next one. So this is a little bit different. This one doesn't really have numbers associated with it. It's just kind of a string and then ends with amine. So we can kind of do the same thing here, but it's a little bit different. So if you're trying to name ethers or amines or something like that, I would recommend a slightly different tactic. I would one, identify if it's an ether or an amine. And that's pretty straightforward. You're just going to look at what's at the end of the molecule. Okay, and then number two, I would just draw out all of the pieces leading up to that ether or amine word. We'll go with fragments. And then we need to combine the fragments onto O or N. Okay, so step one over here, identify ether or amine. We definitely have an amine. So in that case, I would always just kind of draw out a basic amine where I know that it's a nitrogen with 3 bonds to carbons or hydrogen. Okay, I've got carbons or hydrogens as options here, but really I have 3 kind of connection points that need to be taken care of on this nitrogen. I can't just leave one of them open. It either has to be a hydrogen or a carbon. So then I can look at the rest of the pieces here. So if I'm looking here, propyl, if it doesn't have iso or anything in front of it, it's just going to be the straight chain version, 3 carbons. Ethyl is going to be 2, and then methyl is going to be 1. Okay, so if I'm looking at this, my nitrogen here has 3 connection points, and all of these have 1 connection point. So the only way to get those all combined together is if I just kind of arrange them around this nitrogen. So if I have this nitrogen and I've got propyl on one side, ethyl on one side, methyl on the other side, and then I've got my little lone pair, that is my completed amine. Okay, so in some ways it's easier because you could just kind of draw all the pieces out and then glom it all onto O or N. But that's kind of how you want to attack these types of names. So this is the most important thing that I want you to pick up from the nomenclature section, is just being able to draw structures if you are given the name. The opposite direction where you're given this and then you have to come up with the words is a little bit harder, and there's a whole lot of notation that's involved in terms of, you know, where you put hyphens, where you put commas, and that just is kind of unnecessary for all this. So this is what I want you to be able to practice and be good at. So as always, let me know if you have any questions, and I'll see you all later.